This video marks the beginning of the GRE2 class, makeup session for hour 2 of data analysis. And the topic in this hour is probability. So on the board I have 4 mathematical concepts associated with probability and the operations that they're associated with. So the basic concept of a probability is analogous to division, because a probability is always a fraction. So when you see a probability, you should always think, I'm going to have to divide, or I'm going to have to form a fraction. When you see the word and, you're going to associate it with multiplying, times. When you see or, you're going to associate it with adding, plus. And when you see the word not, you're going to associate that with subtracting, minus. So the purpose of this hour is to understand exactly how these interpretations are made. We're going to come back to the and or not a little bit later, but our very next step is to just go over some basic problems, understanding exactly how to set up a probability as a fraction. The basic concept of probability involves finding a ratio between numbers of things, or a number of ways that things can happen. So the basic question posed in the abstract is, if you select a choice, what is the probability that it is a success? So in probability class, we basically treat everything like it's either a success or a failure. So we can illustrate this really easily with this little candy dish. This candy dish has 4 pieces of candy in it. There are 2 mints, a butterscotch, and a cinnamon. So, for example, the question might be, if you select a candy from this dish, what is the probability that it is a mint? Okay, so the number of successes is basically the top of the fraction, and the number of choices is on the bottom. So, and when I say n, I mean number of. So what we see here, if you select a candy, that means that we put candy on the bottom of the fraction. What is the probability that it is a mint? This is what we're defining as a success. So now we have to count the mints within these candies. It's usually easier to set up the denominator first. How many candies are in the dish? 4. And out of those 4 candies, how many of them are mints? 2. So the probability here is 2 out of 4, which of course reduces to 1 and 2. So again, let me draw your attention to where things go within the fraction, because that's the important part. If you select a choice, then the number of those choices altogether belongs on the bottom of the fraction. What is the probability that it is a success? And that number goes on top. Now notice that we're only counting successes within the choices. So let's do an example of how that's important. In the next example, we're going to say if you select a state of the U.S., what is the probability that its name begins with A? So remember again, the denominator is always a little easier to figure out. So since we're selecting a state of the U.S., the number of states would be on the bottom. And of course, there are 50 of them to choose from. Okay, now on the top, the successes means names that begin with A. But I don't want to count all the names that begin with A. I don't want to count Andrea and Alexander. I only want to count names beginning with A within the 50 states. So I'm kind of restricting my attention. I only want to be looking at names on the condition that they're names of states. why this is called a conditional probability. So how many states begin with A within the states? And there are 4 of those: Alabama, Alaska, Arizona, and Arkansas. So the correct probability is 4 out of 50. And again, it's best if you know how to reduce that and turn it into a percent or a decimal. That's not today's lecture, but I hope that you're comfortable with all of that as well. Let me discuss briefly the most common error that students have with setting up probabilities, basic probabilities. The most common wrong answer to this question would be 1 out of 4. And students' faulty reasoning in here is, well, there are 4 states that begin with A. So if I need to pick one of them, then I guess the probability would be 1 out of 4. Okay, that's a misguided interpretation because it's not accounting for the fact that you're really choosing from among all 50 states, and there are 4 successes that count. So I hope I've disavowed you of that common error.